Hi, I am Gilles Barbier, and I'm very excited to talk at this Pulsar Summit about Infinitic for the first time at a conference. A bit of background about me. I have been building workflow engine for nearly 10 years now, mainly for SaaS services. The past year, I have gathered all this knowledge into Infinitic, an open source project based on Apache Pulsar. If you are interested, please subscribe to my Substack here. I publish updates about once a month. In today, what you will learn what Infinitic is and how it can help you build an infrastructure of distributed microservices, how it provides an event-based RPC mechanism, and how you can use Infinitic to code complex business requirements involving multiple microservices. We'll see it make your infrastructure scalable, resilient, observable. And I will talk also about different features, status, and roadmap. So what is Infinitic? Infinitic is an event-based RPC framework for building distributed microservices on top of Apache Pulsar. It's also a very powerful orchestration engine that you can use to code your business requirements involving multiple microservices. Instead, for example, of relying on choreography or Saga patterns. This workflow engine is actually pluggable into an existing infrastructure. For example, if you have already a Kafka, you can plug Infinitic into it to orchestrate workflows from there. Let's talk about microservices. As you know, these microservices should be loosely coupled, communicating over a network. And most importantly, you should be able to maintain them and deploy and scale them independently. One way to do that is to have a direct synchronous communication over HTTP through a protocol like HTTP or REST API, or gRPC. Usually for internal microservices, gRPC communication could be preferred, as it avoids to define your REST API, which is actually an additional layer of complexity. This architecture seems simple, but actually it already introduced some additional needs, such as a service mesh, for example, to pilot the details of the communication between services, such as the location of each services. This pattern is very popular, probably because it is very familiar, quite easy to understand, but it's also more and more viewed as an anti-pattern. The reason why is that it makes your infrastructure brittle. For example, you can break the services only because all its resources are waiting for another broken service in this synchronous, in this chain of calls. So today, people tend to prefer asynchronous communication with an event backbone. And of course, this is where Pulsar is a great piece of infrastructure. But to build an event-driven architecture, you need to do a lot of work, actually. You need to decide on the taxonomy of events. You need to decide for a service which events is going to listen, to react to, which event it produces. You need to decide about the organization of topic. You need to decide to learn a lot about Pulsar, the schemas, the producer, the consumers, the topics, the syntax, the type of subscriptions, this type of things. And also, later you will have to handle the orchestration of the service with techniques like choreography, and you have to decide how to handle technical failure and so on. If you use Infinitic, which is again an event-based RPC framework, the only thing you have to decide to is actually the interfaces of your services. Then, based on these interfaces, Infinitic provides clients and workers SDK that hides the complexity of building this infrastructure using Pulsar. Of course, you can still have a look if you want inside what happens inside Pulsar. For example, using Pulsar Manager, it's your infrastructure, you can look at it. But you do not have to bother again about some technical decisions that are not actually directly related to the business requirements. How it works. To create an Infinitic client, basically you can do that only from a configuration file that will define where you can find your Pulsar. And to create services, which is basically a worker, which is basically a wrapper around your services, you can start it from a config file, where the config file describes also where you can find the Pulsar, and also for each specific task, for example, what is the implementation of the corresponding class. And you have some other settings, such as, for example, the concurrencies and so on. So, given that, and so that's all you need. It's you can, based on the interface of a service, you can create a stub here, stub of the service, and then trigger the execution on one of the worker, the execution of a task, for example. When you do that, the Infinitic will actually serialize the parameters, the card here, send them through Pulsar like an event. The worker will listen to this event and start process the request, and it can even send back the output if you use a synchronous syntax for the communication. For example, here you have a synchronous syntax, and then the worker will send back the output, and it will be deserialized on the fly, and you can use it there. If some failure occurs, the worker will automatically catch the exception and use a method defined in the worker, in the task, sorry, to define your retry strategy. For example, you can here the default is it actually the default configuration, which is a typical retry strategy with an exponential backoff strategy. So the message will be sent back to Pulsar and will come back later to be reprocessed. And once the processing is successful, is completed, then the output can be sent back to the client, for example. So you can see here already has Infinitic improved the reliability of your call or your infrastructure. But where Infinitic shines particularly is everything related to orchestration. So if you have a RPC mechanism like that, let's say that your application requires to request 3 services like this one, for example. You have different ways to do that. You can chain, like it's described here, you can chain the microservices, but then suddenly you are forced to distribute the logic, the business logic, a little bit in each of these services. So you lose the ability to make quick update on your business processes and to easily understand what actually happened in your infrastructure. So this is what happens when you have an event-driven architecture based on, for example, on some choreography. It's very difficult to understand what happens actually. You can also have some another way to do is using this RPC mechanism. You can actually have something equivalent to a controller that calls the 3 services sequentially, for example. It works, but it brings some other problem. For example, if this application breaks and restarts from another message, for example, this services will be called multiple times. So you will have maybe if they are not idempotent, you will have duplicated services execution. And this is because the state of the workflow is not saved anywhere. And also, you cannot really do this type of strategy if your workflow takes time, for example, 10 minutes or a few hours. So, and maybe sometimes also you need more sophisticated scenarios, such as, for example, processing all these 3 microservices in parallel. followed by a confirmation, but just only when you have completed the 3 executions. So for the situation, Infinitic provide a workflow SDK actually. This workflow SDK is able to handle those requirements in a pure event-driven manner, so in a very scalable way. This SDK introduced some workflow workers dedicated to orchestrate actually other services. So this worker are coupled with a database, which is a Redis database currently, and we'll talk about that later. And this database will automatically store the state of the workflow. So in a workflow, it will be perfectly fine to write this type of sequential call, for example, because the state of the workflow will be saved, and if the workflow has to has to restart, it will be start only where it ended previously. The way to make it work is similar to the task. Actually, you have some workflow worker also where you define the address of Pulsar, but also the name of the workflow and the class that implements the workflow. And for the clients, it's the same that for task. You can asynchronously or synchronously dispatch the workflow. Everything is event-based. So if you send them synchronously again, you have a communication of events within your infrastructure, and then one event will come back to the application to return you the output. This is an example of workflow. Workflow are coded using the provided SDK, which has already a rich set of features. The most important feature is to be able to automatically save the state, the internal state of the workflow, and as I say, to replay its execution without triggering the service already code. For example, here, we have a quick example where we ask to start these 3 bookings in parallel because we have an async syntax here. So we ask we request the execution of the 3 services in parallel. And then this line is here to request that we are waiting for the completion of 3 of them. And only then we can send the confirmation email. So the coding of all this workflow is all in these 5 lines. That's it. So if you are curious about the possibility of describing the workflow with the DSL like this one, you can read this article where you will have more details. How does it work behind the scene? Everything, again, is event-driven. We use a lot of features of Pulsar to do that. The most fundamental one is to use to be able to create topics on the fly, for example, and also to use a key shared subscription for with a workflow ID as a key for the workflow engine. The workflow engine is actually embedded in the workflow worker. And by being able to use a key shared subscription, we have the guarantee to not have race condition when we update the state of the workflow. And this feature actually provide the guarantee of consistency when processing the workflows. We use a lot of other features, such as the delay message, that are used to manage time. If in your workflow you need to wait for 1 hour, for example, we will send a delay message with a 1 hour delay. And then we will be able to receive this event, and we will be able to handle it. Currently, as I said, workflow states are stored in a Redis database, but what I would like to do later is to store the states using the stateful functions. So inside, the idea and the philosophy of Infinitic is to limit at maximum the additional infrastructure you need to run Infinitic on top of Pulsar. Ideally, what I want to reach is that be able to tell you if you run a Pulsar cluster, you are able to run Infinitic. today, the stateful functions are not ready for production, so it's not yet possible, but it will be as soon as they are ready for production. Again, if you are interested in more details about how this works, I have here an article under the hood of an event-driven workflow as code engine that you can refer to have a deeper understanding. And now I want to give you a quick overview of the feature you can have with this workflow engine within Infinitic. We have already seen that you can have sequential tasks. So here, as described previously, the M2 task, for example, microservices, will be called only after the completion of the first one and can use the output of the first one if needed. We can have also some child workflows. Child workflow, as you can guess, is, for example, if I ask for the synchronous completion of a child workflow, it will in the background, I would say, complete this child workflow, and only when this method is completed of the child workflow, it will come back to the parents and resume the parent workflow. Events, actually, it's more than external events. The idea here is that you can send signals or external events to running workflows. It can be very, very convenient, for example, if you have processes. For example, you're looking for the validation of someone, of a manager. And the validation is provided by a click on a UI, and the click on a UI can actually trigger to send this information to a running workflow. The running workflow will catch this information and decide what to do next. And this can be very, very convenient. Also, another way to use that is, for example, you have some Kafka, some events in Kafka already, and you throw them to running workflow to be able to operate some workflows based on this event. I come to that later. You can wait in a workflow. You can wait for a duration. You can wait for example, 4 hours, or you can wait, for example, for next Monday at 8 p.m. Fan out. So of course you can fan out some tasks, some calls. So here in this example, the B2 task will be done after the B1. And the A3 will be done after the A2, but both will be run in parallel. And you can fan out thousands of tasks in the same workflow if you want. You can fan in those tasks. So actually, Infinitic has quite a powerful syntax to fan in this type of tasks. So you can ask for the completion of a task. You can also wait for the completion of a timer. So, for example, you can say, I'm waiting for the completion of this task, or the completion of this timer, or the receiving of an event, for example. You can combine any logical combination of this type of instruction can be done. It's quite powerful. Tags is a powerful way to reach workflows. When you dispatch a workflow, you can actually add a tag, multiple tags on them. For example, a typical tag will be a user ID or an order ID. And if you want to cancel all the workflow related to this user, or if you want to send an event to all workflow related to specific subject, you can use tag to do that. And tags are used, for example, to build to use Infinitic on top of an existing infrastructure. If you have Kafka, for example, already in your infrastructure, you can still plug Infinitic to it quite easily. Typically, you will have to install a dispatcher. The dispatcher will consume your Kafka events, and the dispatcher contains an Infinitic client. And for some of the events, you will trigger some. You will start some workflows. And for some of the, typically we start the workflow with tag, again, the user ID or the other ID based on the property of the event. And for some other events, you will send this event to running workflows, again, based on the tag that you can find in the event, such as order ID or user ID. This way, the dispatcher is dummy enough to not depend on the implementation of the workflow, and so in a way that you can update your workflow without having to think to update the dispatcher. So it's a powerful way to plug in Infinitic into an existing Kafka, for example. Another great advantages of defining workflows with plain code is that you can also create your own DSL if you need to. It's not easy to understand usually, but one way to feel that, to understand that, is, for example, if you have this type of JSON that defines your workflow, it's a very simple one with a welcome email awaiting, welcome email waiting, welcome email, for example. Then you have this email, you have this JSON, sorry, and then a simple map inside the workflow. A simple map is actually all what you need to build this workflow with Infinitic. Here, the function run task will take a node of this JSON and will actually, using an Infinitic client, dispatch the corresponding task. That's it. And so maybe you realize now that you're having a tooling like Infinitic is very powerful because you can run in code your own workflows for your need in a lot of subjects are possible, a lot of applications, but you can also use them, for example, with some configuration file, or you can use them with a UI that you define that will create a JSON and that you will execute like this. You can even possibly re-implement some specification, external specifications, such as the Amazon state language used for the state function or the specification of serverless workflow. Regarding Infinitic, the last Pulsar hackathon, we did the first analysis of the performance. First work was a workflow with 6 dummy tasks, and on a single MacBook Pro where everything was installed, including the worker and the Linux and everything, we reached 20 workflows per second completed on a single MacBook Pro. And later, with Splio, which is actually the French marketing company I work with in France, they managed to reach 150 workflow completed per second on a quite small production cluster, relatively small. So 150 workflow completed per second, it's quite a lot. It's 13 million per day. And you can have a much more workflow running because when you can have tens of millions or hundreds of millions of workflow running, because when nothing happens in this workflow, then you don't have any activity in Infinitic. Here, we are talking only about completion. Okay, but a very important feature, of course, of Infinitic and are the ability to build a very resilient infrastructure. Of course, we benefit here of the great features of Pulsar of all the guarantees that Pulsar brings to you already. So, for example, the guarantee that all message will not be lost. No message will be lost. And as you can scale the task worker horizontally, you have also the guarantee that your message will be processed. And the same thing for workflows, actually. You can scale them horizontally. And so you have the guarantee that the workflow will actually run. If you have some bugs inside the code, you still have the automatic retry process. If a service is completely shut down, another service will actually take the work later. And if you have some bug that prevents you completely, for example, to run a task, you can still, in workflows, handle this failure. And so so you can create like this unstoppable workflow. So you can be sure, you can have the guarantee that your workflow will be processed in a way or another. And you can build alerts, or you can build different process, different options to decide what to do depending on the success or not success of your task. So quickly, current status of Infinitic. Current version is 0.6.5 actually. It's ready for some proof of concept or MVP deployments. I'm targeting a stable version for the end of the year. And I'm working on today with a marketing company, Leo actually, that is using Infinitic to power the next generation of their own automation marketing engine. So they have a Scala event, Scala backbone, Kafka backbone, and from there we take the event and are able to use the workflow engine on top of it. The roadmap, the main feature I would like to add currently is the dashboards. Of course, it's Pulsar. It's based on Pulsar, so you still have all the tooling of Pulsar. You can look at the topics and see the message and see what's happening under the hood. But ideally, I would like to add dashboards to be able to see, for example, for one instance of workflow, what are precisely all the steps and all the details of the execution. Ideally, I will base this on Pulsar SQL. It could be a bit slow because, as you know, you can't index currently data in Pulsar SQL. But I would like to reach this point where I do not need to add additional infrastructure. Yeah, as I said, it will be very nice to deploy this engine has a stateful functions to benefit from the state, the ability to store the state locally in Pulsar. More workflow features are coming, and I would like to improve also the protobuf integration that could help to develop more languages. I mean, for example, Node, Python, Go, and maybe I need some help there. If contributors are absolutely welcome. That's it. You can see the code on GitHub. The documentation is online. Please subscribe to my Substack if you're interested. Have a look at the Infinitic website. And I'm very happy to answer any question you have. Thank you very much for being here. And please have your questions. Thanks. See you.